All right, let's go over this assignment with the type 1, type 2 error and power, and then those mechanisms that change those probabilities. So this first problem, we were asking, what is this power of the significance test doing? And just straight, you can look straight at your notes. It's that ability to reject the null hypothesis if it is indeed false. Power is the probability to reject the null, if it's false indeed. Okay, and that's the ability to detect an effect if there really is one. So if we need to go with HA, we're able to detect that. So there you go. Okay, so on number 2. Again, it's asking about what power is. So I think to the definition that with power, HA is false, and I want to be able to detect HA. So the new optics programs work significantly better than the old ones because I want to be able to detect that because they do. All right. And so then that is what answer C is saying, is that we want to be able to detect that the new optics work better when they actually do work better. Power is a good thing. Power is allowing us to make a correct decision about rejecting the null hypothesis. All right. So number 3, I kind of went through some thought processes. First, when I saw this, I thought it was going to be, again, doing a power definition, but it ended up not doing that. Now, here it just basically said, which of the following situations would power be the highest? So on that, then what I'm looking for is, so see what I did was I kind of pulled in this graphic right here. But also we talked about this, I had added this as well about this effect size. So we're talking about we want power to increase. So let's then look at what these things are that make power increase. Alpha is going up. So we have control over alpha. So the highest alpha will make the power increase. Okay, N, sample size, the larger N will make power increase. And then this is why I'm not sure how this fits into this graphic exactly, but I want the HA, the farther that HA is away from the null hypothesis, and that's pushing all the data out there. So more of the data is giving me the ability to reject the false null hypothesis. So that's what I want to happen there. I wanted to find the one with the largest alpha, the largest sample size, and the HA is farthest away from 8%, because 8% is what the null hypothesis was. So the one that meets that requirement was A, 16, or A, because it had the farthest HA, biggest alpha, and largest N of the choices. All right. So here we go. Which of the following would be a type 1 error? So our type 1 error, if the null is really true. Okay, so I kind of made myself a little note down here. So the reality is the new mouthwash is the same effectiveness as the current mouthwash, okay, if the null is really true. But we get a sample that makes us think that the new mouthwash is greater than the current. So the scientists would conclude the mouthwash is effective when it actually is not. Okay, now, FYI, when I read answer choice C, scientists conclude that mouthwash treatment is effective when it actually is. I mean, for one, that's not an error. So, you're making the correct decision. And that's what happens with E also. The scientist concludes the mouthwash treatment is not effective when it actually is not. Okay, so again, that's not an error. The one that is the type 1 error is B. Okay, next, again, we have this other one that's asking us, now we're asking about decreasing of the probability of a type 2 error. So I went and I found the graphic that showed this little orange circle going down, so beta going down, and then I know what's going on. So the significance level is alpha, It says it decreases, and that's not true. The alpha is increasing. Okay, this says the standard error size is increased. That's the same thing as standard deviation. So see, look here over here on the right, I can see standard deviation is going down. So that's a no. The true parameter is closer to the null. Okay, so what if this one has the true, so in order for this to happen, the true HA is farther from the null, okay? And then our sample size is increased. Yes, that is what this is showing, is that N is increasing, okay? So that's how I went through the source of using this graphic to help me decide what that is. Okay, number 6, it says alpha is 0.05. Power is 0.63. What is the probability of making a type 2 error? So that's beta. So remember that power plus beta make the whole data set in HA. So power plus beta is 1. So I did not even use this information about alpha to determine beta because it's based off of the value of power. So I just then took 0.63 away from 1, and what was remaining then was beta. All right, and number 7, I actually didn't really like. I thought they gave a very weak, non-complete interpretation of p-value, but they got only 2 of the 3 components that really needs to happen. P-value is the probability. So p-value for this test is this. So out of all the possible samples, 24% of them, not this opposite. And then we wanted the probability of getting these samples or something more extreme. Well, this problem was about getting a hypothesis where the alternative is talking about we want more than 67% of adult emperor penguins are female. So more extreme is more than 67%. So that's why I have this in purple. More than 67 more of the adult emperor penguins who are female. Not less than, like choice C, and A doesn't include the or more extreme. It just says it is 67. All right, now we have this problem. Takes us through lots of things here. So here we go. This is the Macy's department store problem where they're trying to increase the proportion of male shoppers who buy something based on changing some coloring patterns, think changing the decor of the store, that kind of thing, the marketing. Okay, so the parameter P is the proportion of Macy's male shoppers who purchase something. Okay. So the null hypothesis is that it's 12%, but they want to see if you know what I should put in here is the treatment. I should say after the treatment has been, I should add that in here. The proportion, after the new marketing campaign. So remember, I'm wanting to see if, as a result of this treatment, the new marketing campaign, what the proportion of male customers buy something. So I start off saying they buy that the new marketing campaign does not help, and they buy something at the same rate as before. And then the HA is the marketing campaign does help, and it made this proportion that buy something greater. Okay. So in context, the reality is type 1 error. Type 1 error. If the null is really true, so the reality is the proportion stayed the same. So the marketing campaign does not help, but we get a sample that makes us think that the marketing campaign does increase sales. So what happens as a consequence? It says, what's an impact? Well, they definitely waste their money then, because Macy's is going to spend money on the new male-oriented coloring and patterns that do not actually increase male purchases. Okay, and then C. In this context, describe a type 2 error and the impact of such an error. So that's failed to reject a false null hypothesis, type 2 error, type 2 error. So the null hypothesis is false. So the reality is that the new campaign is increasing mail purchases. But I didn't detect that. I failed to detect HA. So I think it didn't do any good. So the Macy's, the impact is missing out on the opportunity to have additional purchases. Okay, so they're missing on that opportunity to invest in the new marketing that will increase the revenue for higher proportion of purchases. All right. D now says, based on this 90% confidence interval, they get this 11% to 17%. What would you end up concluding from that particular interval? Well, the key that you're looking for here is the null hypothesis in this interval or not in this interval? Well, clearly 12% is in the interval. Therefore, 12% could still be happening. It's plausible. So I do not have evidence that the new marketing campaign has increased sales. So what would this interval have looked like if I did have evidence that the new marketing campaign increased sales? Well, the whole entire interval would have been above the 12%. Okay, it would have been higher than and not included the 12%. All right, now let's look at this. What level of significance did the research department use? Well, that comes from the fact that it was 90% confident. So 90% is in the middle, which puts 5% on each tail. So that's the first step to figure this out. Then the second step is to figure out what tail did they use. So this problem, HA, was a tail about the one tail, upper tail. You're seeing if it has increased. Therefore, it's this top part. So that is where the rejection region is to be able to conclude they have higher sales. Okay. So that alpha then is 5%. Okay. Well, what's going to happen if they decrease the alpha to 2.5%? So what I did was I went and I copied this little graphic here on the picture that showed me the alpha going down, decreasing alpha. Okay, so decreasing alpha. All right, so then, okay, so remember advantages and disadvantages. If an error goes up, that's bad. So that's a disadvantage. So here, type 2 error goes up. So that's bad. So that's why probability of type 2 error increases is a disadvantage. Okay. And then an error, the probability of an error going down, less likely to make that mistake is a good thing. So if alpha decreases, then so does the probability of a type 1 error decreases. So that's an advantage. Then now let's see where power plays into this. What's the power play? So so at this point, then you say, okay, well, if power increases, power is a good thing. We want more power, need more power is the baby Einstein's thing. So we want to increase power, and that would be an advantage. But if power decreases, then it goes in the disadvantage area. And so then that is the right here, power decreases. Okay, what happens if they do the trial period for 2 months instead of 1? Well, that means that N is increasing. Did I do that right? I just want to, did they do this for 1 month up here? I don't know. So I'm assuming that it was 1 month. So, they extend the trial period. So they're making it longer. So there's how I knew N increased. So I looked at my graphic that shows N down here increasing. Well, that is in the power increases 1. All right, so H is a question where you just have to use some common sense. You're expected to kind of use your worldliness knowledge of what's going on to figure out what that is. It says over the trial month, they did conclude that the proportion of purchases increased to 18%. So why might they still, even though that happened, choose to not go with the whole new campaign and invest in that? Well, in the real world, they're going to do the cost analysis and see is, it is possible that the increase in the proportion of male shoppers, even though it went up 6%, the cost of all of that new marketing campaign, switching all the things over, if they're changing the decor in all the stores, that's quite costly, all those kinds of things. It could be that making that change is more costly than the increased revenue they're going to see from that additional 6% of purchases. So that would be why, even though they know there's an increase, then they do that cost analysis and see it just was not enough of an increase to make the new campaign worth it. All right, so there we go. That is your assignment that you did on the power and those mechanisms that change power and the probabilities of type 1, type 2 error and power.